because there's a lot of terms today, and drawing examples of these terms doesn't really apply. Okay? So, fold it in half, and then if you want to use this as a study guide later, you can cut along half of this right here, and then it'll be like a little flip book. But we're not going to cut in class and waste time doing that. Okay, so right now you're just folding it in half. If you want some highlighters and stuff, get that out. Okay, inside on the left is going to be an example and the right definition. So example, definition. Okay, first word that we are looking at is induction, okay? Induction or inductive reasoning. You could see it either or, okay? The definition is reasoning that uses specific examples to make a conclusion. Okay, so reasoning that uses specific examples to make a conclusion. Okay, the example that we're going to use is the amount you study and the grade that you get. Okay, the more you study, the better the grade. The less you study, the worse the grade. Okay, I know that for some of you this doesn't always apply, but majority of the time, this is how it works. Okay, so amount you study for a test and the grade you get. Okay, that's our first one. Next one is deduction or deductive reasoning. You might want to write that on there. Inductive reasoning. Deductive reasoning. Okay. Deductive reasoning is reasoning that uses general rules to make a conclusion. So reasoning that uses general rules to make a conclusion. Okay, examples of this would be the little rules that help you do things like righty-tighty, lefty-loosey. Has everybody heard that before? Okay, another one is I before E except after C. Anybody else have another one? Those are the two that I could come up with.
A stitch in time saves 9.
A what?
A stitch in time saves 9.
I've never heard that. What's it apply to?
Basically, doing something now can save you. Basically, doing something now can save you a lot of effort in the future.
Oh, nice. I've never heard that. Okay, it also doesn't have to be something like super rhymey. Yes.
Would like history count, in 1492 when the Soviet ruled?
Okay, that's a little jingle, but it's more like a rule for like the reason you would do something. Okay, so it could be even more generic, like, my mom told me that apples are red, so if I pick up this red fruit, I think it's an apple. Okay, so that's a very generic thing, and obviously that's not always true, okay, because it could be a strawberry or whatever, but I'm using deductive reasoning to think that that's an apple. Okay, so it could be just very general rules. Okay, next one, counterexample. Okay, a counterexample is a specific example that shows a general statement is not true. So a counterexample shows that a general statement is not true. Okay, so on a test you might have a statement that says all birds can fly. What would be an example of a counterexample?
An example of trueness?
Or what would be a counterexample? What's a bird that doesn't fly? A penguin. An ostrich. Okay, so you would just list an example. Okay, this also can be used for math. Okay, so let's say I say the sum of two numbers is always even. Give me a counterexample.
3 plus 2.
3 plus 2 is 5, so that's odd. Okay, the product of any two numbers is odd. What's a product? A multiplication fact. Okay, or multiplication. And so what would be a counterexample? 3 times 3 is 9. Okay, so think along those lines as well. Okay. Next one we have, what is it? Conditional statement. Okay, our conditional statement is a statement that can be written in the form if P then Q.
Basically a hypothesis.
We're getting there, but yeah. Okay, P then Q. So, our conditional statement that we're going to use on the rest of these examples, okay, is if I do my homework, then I will do well on my test.
Do we have to use this example?
I mean, I'm going to use the same example all the way down, but if you want to make your own, you can.
I am.
Okay. Okay, so if-then format. Okay, so you will commonly see things like this too. So how we notate a conditional is P with the little arrow Q. Okay, the next one is the hypothesis. So you have a hypothesis and a conclusion inside of your conditional statement. A hypothesis and a conclusion. What do you think the hypothesis is?
Should be a statement. If I do my homework.
Okay, so the first part. Okay, so whatever follows the if. It's not if I do my homework. Okay, it's I do my homework. That's your hypothesis. So the P part. Okay. So, the part of your conditional that follows if. Okay, so the P. Okay, rewrite your example again if I do my homework. Okay, and I'm going to highlight my hypothesis. Okay, what do you think the conclusion is?
I will do good on my test.
I'll do good on my test. You have a vocab quiz on Monday, and it will include all the words, including these from this week. I'll send out a Quizlet, same thing I did last time. Okay, so hypothesis is the P part. Okay, there's a P in hypothesis, if that helps you remember it. Okay, and then conclusion is Q. Okay,
Q by itself sounds big.
True. Okay, and then make sure you do not include the words if and then when you state the hypothesis and the conclusion. It's the part that follows after. Alright, so the trickiest part of today is what's to come. It's not necessarily difficult, it's just 3 rules that you have to remember. Okay, and the first one is the converse of the conditional. Okay, so how you form the converse, okay, is by flipping your key and the P, oh my gosh, I can't talk, the Q and the P. Okay, so it's formed by reversing order of hypothesis and conclusion. Okay, so if Q, then P. Okay, so using our same example, okay, if I do my homework, then I'll do well on the test. How would that look like for the converse? Yes.
I will do well on my test if I do my homework.
Okay, we still want to keep it in if-then format, so you can do it. Just reword it.
Oh, okay. If I do well on my... No, hold on.
Yeah, go ahead. If I do well on my test, then I did my homework. Okay, so sometimes you have to change up the verbs in order for your sentence to be grammatically correct. Okay, but very good. It would say, if I do well on my test, then I did my homework. Okay, so you still want to keep it in if-then format. Okay, the next one is the inverse. Okay, it is formed by negating the hypothesis and conclusion. What does it mean to negate something? What does it sound like? or spell like negative, okay? So we're making it negative, okay? So that looks like not P, then not Q, okay? So those little squirrelies are not, like literally the word not. Okay, so using our conditional statement, if I do my homework, then I will do well on my test. Okay, how does the inverse look?
If I don't do my homework, then I won't do well on my test.
Very good. If I do not do my homework, I will not do well on my test. Okay, so highlight those nots to make sure that you realize that you need to negate both. Okay, what happens if when I'm negating, I get not. So say it was like, if I do not do my homework, what is that really saying? If you do your homework. So just like when you add and subtract or multiply, when you have double negatives, okay, it's always a positive. Okay, so the same thing happens here. You don't say not, okay, it is I do my homework. Alright, last one, contrapositive, okay, formed by switching the order of the hypothesis and conclusion and negating both. If I told you to put that in simpler terms, that definition, how could you state that?
It's not Q, then not P.
Not Q, then not P, or negating what?
Negating
P, Q, and P.
the converse.
The converse, okay? Or you could just say negating the converse. But if you forgot what the converse was for whatever reason, I'm going to say switch the order of the hypothesis and conclusion and then negate both. Okay? So, very good. Not Q, then not P. Okay, so using our same conditional statement, what will the contrapositive look like? Yes, Justin.
I will not do well on my test if I did not do my homework.
Perfect. Okay, so if I do not do well on my test,
Does it have to be an if then?
yes, always still an if then. So if I do not do well on my test, then I did not do my homework. If you don't have it written word for word and you change your verbs up a little bit, that's okay. The one that you'll see on your skills check is simple. Okay, so if I do not do well on my test, then I did not do my homework. Alright, so that is our vocab for today. Now we're going to put it to use in our notes. But does anybody have a question over the vocab? Okay, so those last three, you just have to memorize. Okay, you've got to memorize the order. And hopefully after we get through the notes and do some practice, it'll just become repetition and it'll be like second nature. Alright. So, like I said, if you want to make this a foldable, you can cut right here on all of these lines and then you will just use it as a little study guide. The vocab quiz over this stuff is on Monday. Yes.
Will it be the same format?
Same format, fill in the blank, and I'll send the Quizlet out. Those of you that studied the Quizlet the first go around know that it's the exact same thing. Literally, all you have to do is study. Okay, but for some of you, that's asking a lot of you. Okay, so put that to the side. You can use it as we go through the notes if you would like. Okay, first thing on your notes is 4 questions. Okay, it says inductive versus deductive reasoning. So those first 2 definitions that we wrote down. Okay, with your table, go through, it's going to take you about 2 minutes, and label whether you think they're inductive or deductive reasoning. There's 4 examples there. Go. Talk with your table. It requires conversation. Do not do it by yourself.
Decide if the following individuals are using inductive reasoning or deductive reasoning. Here, you wanna read number 1, Kyle? Chloe has been told that all basketballs are orange. When she sees the ball is not orange, she concludes that it cannot be basketball. Is that clear?
Alright, here we go. Number 1, Donovan takes 5 minutes to arrive to school from home for 10 school days in a row. He concludes that he can always leave his house at 8:55 to get to school by 9. Deductive or inductive?
Inductive.
Inductive. Very good. Okay, number 2. Lily has been told that all basketballs are orange. When she sees a ball that is not orange, she concludes that it cannot be a basketball. Inductive or deductive? Deductive. 3. Miriam has been told that lightning never strikes twice in the same place. During a lightning storm, she sees a tree struck by lightning and goes and stands next to it, convinced that it's the safest place to be. Deductive. Very good.
Really wrong.
Number 4. Alex is told that all printers can print in black and white. He has a printer at home and concludes that he can print his homework in black and white. Deductive. Very good. Okay. The next 4. Simple, okay? Write the following statements in if-then format. Okay, so I want to convert these 4 statements into if-then. Okay? So how could I write all triangles have 3 sides in an if-then format? Yes.
If the shape of the triangle, then it will have 2 sides.
Very good. Or if you want to even write less words than that, that's fine. If it is a triangle, then it has 3 sides. Okay, all dogs go to heaven. How could I rewrite that? Then it'll go to heaven. Very good. Next one, a rose is a flower.
If it's a flower, if it's a rose, it's a flower.
Very good.
Flower.
Very simple. If it is a rose, then it is a flower. And last one, all right angles are congruent.
If it's a right angle, then it's congruent.
Okay, because it's plural, you would say if they are right angles, then they are congruent. Okay, because we can't just have one thing congruent. So, if they are right angles, then they are congruent. Questions on writing conditionals? We're good? Okay. So now we are putting into practice, okay, our vocab. We are going to write the converse, inverse, and contrapositive of each of these statements. Then we're going to decide if they're true or false. So after you write that statement, think logically and say, okay, could this statement be true or false? Answer it. If it is false, provide a counterexample. Okay, we're going to do the first one together. If an animal is a duck, then it is not a rat. How would I write the converse?
A Q then P.
So if Q, then P, so she told us that we need to switch it, so how would that read?
If it's not a rat.
Very good. If it is not a rat, then it is a duck. True or false? Okay, what would be a counterexample? Okay, any animals that's not a rat, so you could say a cat, a dog, alligator, whatever you want to say. Okay, inverse. Okay, in form of Q and P, what is the inverse?
It'll have the not.
Okay, you're gonna negate both. So if not P, then not Q. Okay, so if you negate both, how does it read?
If it's not, if an animal is not a duck, then it is a rat.
Then it is a rat. So notice how when you negate this part here, it reads, then it is not a rat. So that's when you would say it is a rat, because we don't speak like that. We don't say not. Okay, so if it is not a duck, then it is a rat. True or false?
False.
False, and what would be a counterexample?
Once again, cat.
Sure. You can say cat again, dog, whatever. Okay, in the form of P and Q, what is the contrapositive? In forms of Q and P, in terms of Q and P. So look at your vocab. What did it say in terms of Q and P? Did we write it? Yeah. Yes. Very good. If not Q, then not P. And we discussed how it is negating the converse. Okay, negating the converse. So how does the contrapositive read? If it is a rat, then it's not a duck.
Oh, so it's pretty much just the first two combined.
True or false?
True.
True. Okay. You are doing with your table the remaining 3. Okay, and then I'll give you 6 minutes. Okay, 6 minutes to do the remaining 3. Yes, that's fine. And then we'll come back and I will ask people what the answers are. I'm not going to write every single one up here again. Okay, so with your group, do the remaining 3. 6 minutes. Go.
Okay, if it is
This is Coach
square,
Clone.
then it has 4 digits. So
Hi.
if it has 4 digits.
Yes. Up to now, okay, so all of your Algebra 1, all your middle school math, and all of that is Euclidean geometry, okay? We are now going to also introduce spherical geometry, okay, but we're not going to talk a whole lot about it, okay? There's going to be a few key points that you need to know for your testing purposes, but we're not going to do a whole lot with it, okay? In Euclidean geometry is what we do now, okay? We have things called postulates. And a postulate is something that we accept without proof. Okay? I don't need to write a formal proof for 2 plus 2 equals 4. Okay? Or 2 equals 2. Okay? We just take those without proof. Okay? Opposite of that is what we have and what we call theorems. And a theorem is a statement that can be proven. Okay? I can prove the Pythagorean theorem. I could prove that 2 lines are parallel. How would I prove 2 lines are parallel?
If they have the same slope.
If they have the same slope. Okay? So we can prove all those things. Okay? But a postulate is something we take without proof. Okay? So 2 equals 2. A right angle is 90 degrees. Okay? So all of our
Gravity is
definition
attractive.
purposes. Pardon?
Gravity is always attractive.
Gravity is always attractive. Okay. Turn the page. We are going to watch a short, it's like 3.5-minute video. Okay? And you're going to fill in as much as you can here. Okay? You should be almost able to fill in about all of them. Okay? But it's only 3 minutes, and I understand you might miss some. Okay? But we'll fill it in after, but try to fill in as many as you can as the video goes. Okay, next one. Given any straight line segment, a blank can be drawn that has the segment as its blank and one blank as its center. First blank is what?
Circle.
Circle. Okay, so given any straight line segment, a circle can be drawn that has the segment as its radius and one blank as its center. Endpoint. Very good. All blank are congruent. Right angles. If two lines are drawn that blank, anybody get this one? If 2 lines that intersect, very good. Intersect a third line in such a way that the blank of the inner angles of one side. Does anybody know what this blank is? Okay, the sum. Okay, so in such a way that the sum of the inner angles on one side is less than 180 or 2 right angles. Then the 2 lines will intersect each other if extended far enough. This is known as the, it was a postulate, what was it? Nobody got this one?
Euclidean postulate?
No. Close. Parallel.
Parallel.
Okay, so those were just some notes from the video. Okay, now I'm going to tell you like the essentials of what you need to know. Okay, first thing.
That blank, though? What's the essential difference?
I'm about to go over it. Okay, the essential difference between Euclidean and non-Euclidean geometry is the nature of parallel lines. So there are not parallel lines in non-Euclidean geometry. Okay, in spherical geometry, okay, in our video it talks about using a globe to kind of help you grasp the idea of using a sphere as a plane. Okay, in spherical geometry, a blank is substituted for a blank.
A sphere?
Very good. A sphere for a
Plane?
plane. So I just said that. Okay, we'll see if anybody got the last one. A great circle of a sphere is a blank that divides the sphere into 2 congruent hemispheres. It's written on that picture to the right.
Great circle.
A great circle of a sphere is a, oh, just kidding, that's what we're defining. Okay, is a line that divides a sphere into 2 congruent hemispheres. Okay, so if this is your hemisphere, sorry, your sphere, okay, so this is my globe, pretend. Okay, your great circles have to go all the way around, and they have to be able to cut your sphere in half. Okay, so what would be an example of my great circle, or of a great circle? What's something that cuts the globe in half? The equator, prime meridian. What else? Your longitude line. So granted, I know that they represent different degrees, okay? However, they go all the way around and they match up somewhere on the other side, okay? So you could divide your globe in half on any of those lines of longitude lines. Are my latitude lines great circles? No.
No, just the equator.
Just the equator. Very good. Okay? On my globe, okay, how many places do great circles intersect? Two. And if you're using your globe as a reference, like, where are those two places?
On the 2 poles.
On the 2 poles. So your 2 great circles, okay, or 2 great circles will always intersect at 2 points. So think of the poles. Okay, so if you turn the page, it says why can parallel lines not exist in spherical geometry? Okay, so in spherical geometry, what do we call our lines?
Great circles.
Great circles. And what did we just discuss about great circles? They cut the globe in half, but what else?
They always intersect.
They always intersect at how many points? 2. So in order for them to be parallel, can they intersect? No. Okay, so to sum that up, you could just say lines are great circles. And any 2 great circles will intersect. Okay, number 2, how many points do 2 spherical lines intersect? 2. And you can say, think of the north and the south poles. Okay, how does a spherical triangle differ from a triangle in Euclidean geometry? How do they differ? Yes.
And if you were to flatten the spherical triangle out, it would have a curved edge.
Okay, so curved edges. What else?
All of the all of the corners are at right angles.
Okay, and even in Euclidean geometry though, they cannot be all right angles.
No, but all of them can be.
Oh, all of them can be. Okay, so to sum that up, it would just be their angles could add up to more than 180. Okay, last 2 things. The equator and prime meridian are examples of
Great circles.
great circles. Models of the Earth showing its core are examples of what?
Non-Euclidean triangles.
Non-Euclidean triangles are just spherical triangles. Alright, so the 3 big things, takeaways, okay? The difference between Euclidean and non-Euclidean geometry is the nature of parallel lines. Okay, so if you want to highlight these key points, go for it. So that was the first thing, right here. Important. Okay? Next important thing. It's kind of a combination of both of these, but two great circles will always intersect at 2 points. So two great circles intersect at 2 points. Okay, two great circles will always intersect at 2 points. And then the last thing is just the sum of the interior angles of a triangle could be greater than 180 degrees. So the sum of the interior angles of a triangle could exceed 180 degrees.
But technically that isn't true, because what if the great circles are on different spheres, like lines on different planes?
Well, we're talking about just like one plane. You're using a sphere as a plane.
Yes, but what if you have 2 planes, 2 spheres? And technically the great circle on one sphere would not intersect with the great sphere on the other circle.
Okay, but we're just talking about one sphere. One plane. Okay. Questions? Okay, before we take our skills check, I want to do one little quizzes game to help you guys study / review the converse, inverse, and contrapositive. So, quietly, grab your phones.